See, this question is also important because this question was asked as a one marker. Sometimes they are giving the graph in the MCQs. They give 4 graphs and tell you which graph is appropriate. Or sometimes they ask the same question in words and they ask you to draw the graph for that. They ask you to, many times they are asking to draw the graph for that. What is the characteristic of resistivity versus temperature for so and so material? This is for copper. So what happens for copper? As the temperature increases, resistivity increases gradually. But if you are drawing for nichrome wire, the same graph for nichrome wire, it is linear because nichrome is a good that is a bad conductor, or we can say having a good resistance. So as the temperature increases, resistivity is increasing gradually. This is for nichrome wire. This is for nichrome. They can ask instead of copper, they can ask gold. They can ask for silver, or they can ask for something gold, silver, or what else is there? They can ask for aluminum also. So the value is same. The graph will be same. It won't change. Now for semiconductor, like junction diode and all, the graph will be like this. See, this is for temperature versus resistivity. The graph is in this. Is it clear? This is resistivity versus temperature. This is resistivity versus temperature for nichrome. This is for conductors, and this is for semiconductors. Clear? This is semiconductor. Like
second.
Yes, sir. Yes.
So the second equation, how is it rho, sir? Can you explain that?
Second, this one?
No, sir, the formula.
The formula. This is
rho. How did
rho
rho come?
This is the resistivity formula. Temperature dependent. This is the formula which this came from temperature dependence on resistance.
Yeah.
This came from temperature dependence on resistivity.
Oh, okay. Okay, sir.
Alpha is same. What is alpha? Alpha they will give. Alpha is what you call
temperature
coefficient. Okay. What is the definition of this? Temperature coefficient of resistance of. What is the definition of this? The unit is per degree centigrade. What is the meaning of this? Means for 1 degree rise in temperature, how much resistance is increasing? For 1 degree rise in temperature, how much temperature is rising? That is said to be temperature coefficient. Is that clear? Is it clear, all of you?
Yes, sir.
Okay. Please copy this one. If you have any doubt, please ask me. FB for forward bias, RB for reverse bias. Keep that in the mind. Can I go ahead now?
Yes, sir.
What about others?
Yes, sir. Done, sir.
Yes, sir, done.
Ismail, are you understanding?
Yes, sir.
Now, next one is here. Okay, so next I'm going with the drift velocity. There are 3 derivations, as I told you. Drift velocity VD. Correct? V suffix D. Drift velocity. Now suppose there is a wire like this. There is a piece of wire we have taken, and it is connected to a cell. We'll take like this. So this is minus and plus. Current will flow in this way. Current will flow in this. No, yeah. And electrons it will flow in the opposite direction. So when the electrons are flowing, the current will flow like this. So electrons, when they are flowing, they collide with the molecules. Okay, they collide with the molecules present in the wire. And the total length of the wire is what? L. And capital A is the area of cross section of the wire. L is the length of the wire. A is the area of cross section of the wire. Okay. I is the current flowing through the wire. If they collide with each other, these electrons will collide with the atoms present in the substance, and at last they make some displacement. That displacement is equal to L. So we know the formula. Velocity is equal to what? Displacement by time. This already we know. Displacement is equal to what? Velocity into time. Now, here in this case, we are writing L is equal to what? Vd into tau. I'll come to this point later. Why? In the place of x, I have taken length. In the place of velocity, I wrote drift velocity. In the place of T, I wrote relaxation time. I'll write here L is length of wire. L is length of wire. VD is said to be drift velocity. Drift velocity, and tau is said to be relaxation time. Tau is said to be relaxation time. Now, here what happened? There are two forces. F is equal to what? MA, the first formula, and F is equal to Q into E. Q into E. So this is the second formula. So this we are writing F is equal to minus E into E, because electron flow we are taking. So we are equating both of them. MA is equal to what? Minus E into capital E. A is equal to what? Minus E into capital E by M. Clear? This is the formula we got. Next, we have the equation of motion for uniformly accelerated bodies. What is the formula? V is equal to U plus AT. So in the place of U is initial velocity, V is the final velocity. VD is equal to what? Minus E capital E by M into tau. This is the formula. Is that clear? In the place of acceleration, I'm writing this one. And initial velocity is 0. Is it clear? Is this clear? This is the first.
Yes, sir.
This is the first
Yes,
derivation.
sir.
Minus E. The formula is minus E capital E tau by M. This is the formula's first formula. The second derivation here, initial velocity is 0. Keep that in mind. We have substituted all these values in that one and we got the answer. Now, the second formula is we have to prove I is equal to what? NEAVD. This is the second derivation. Now, we know from quantization. What is quantization? Quantization of charge. What is the formula? Q is equal to plus or minus NE.
Plus or minus any.
What is this? The number of the charge on the whole body. The charge on the whole body is equal to what? Total number of charges multiplied with the charge of the electron. Maybe the number is not fraction. It is completely integer. It can be 1, 2, 3, 4. The number of students in a class are 10. It cannot be 10.1, 9.5. We don't have 9.5 students, right? Is it not? Is that clear?
Yes.
We don't have 9.5 students on something like that. So Q is equal to what? Plus or minus NE. Now here, so we have Q is equal to plus or minus N. So now we have number density. Number density is what? Number density means small n. Number of electrons per unit volume. The formula is small n is equal to capital N by V. Implies capital N is equal to small n into V. Okay. So now it implies again N is equal to what? Small n into area into length. This is the formula. Okay. Now we substitute here. Q is equal to what? Q is equal to N A L into E. This is the thing we got, the total charge. Okay, but we have the formula I is equal to what? Q by T. Now we are going to substitute here. I is equal to what? Q is N A L E by tau. Instead of T, I am taking tau. Now I is equal to what? N A. What is L by T? L by T is VD. So NEA. Here we can write NEAVD. Is it clear, all of you? Is this clear? See, this is quantization formula. Started with quantization formula. Number density is number of electrons per unit volume. Volume means area into length. Cross multiply and write area into length. In the place of charge, we are writing in the place of capital N, we wrote NAL into E. Then I got I is equal to Q by T. I is equal to NAL E by tau. We got the second formula. What is this tau? Tau is said to be relaxation time. Time between two successive collisions. Time between two successive collisions. Time between two successive collisions is said to be second. Okay. Now this is second derivation. The third derivation. Third derivation is I is equal to what? We have the formula. I is equal to NEAVD, right? So we are going to do that now. So we start with the next one. Next derivation is is it clear, all of you? These two derivations.
Yes, sir.
Yeah.
Yes,
Okay.
sir.
Yes, sir.
I'm going with the third one now. Third one is rho is equal to M by E NE square tau. This is the third one. or we can write in terms of J also.
क्या कब की रखता है
J is equal to N E square tau V by ml. So now I am going to do this. I have two formulas here. What is that? First formula is I is equal to what? N E A V D. Second formula is what is this? V D is equal to what? V D is equal to minus E capital E tau by M. So now I am going to substitute this V D there. So it will become what? This is 1 and this is 2. So 2 in 1. Substitute 2 in 1. So it will become I is equal to what? N E A V D is what? This is minus. So therefore it will be E capital E minus E capital E tau by M. So that will become I is equal to what? N E square A E tau by M. Clear? This is the thing we got. Now, here we have one more formula. What is that? E is equal to V by D. So E is equal to V by M. I am going to substitute again. Let it be 3, let it be 4. Now 4 in 3. 4 in 3. So what do we get now? I is equal to what? N E square A V tau by L into M. Is it clear? Is this clear? See once again. This first and second, this is first derivation, this is second derivation answer. Now what we are going to do, we are going to substitute 2 in 1. We got this one. Then we simplified. Then we got one more formula. E is equal to relation between V and E. E is equal to V by D. Now substitute back again into the equation. We got this one. Now, what is that? We get here V by I. If I cross multiply this one, if I cross multiply this, V by I will become Lm by N E square A into tau. This is the formula. So what is this? R is equal to V by R is equal to what? Rho. This we got N E square A into tau. A into tau. Now if you want to write the resistivity formula, what is resistivity formula? Rho is equal to R into A by E. R into A by E. So we'll cross multiply R into L by A. Wait. R is equal to rho into L by A. Rho is equal to R into A by E. Okay. So if you cross multiply this, R into A by L will become what? L by L into M by N E square into tau. So the formula is what now? Rho is equal to L into M by N E square tau. This is the next formula. Is that clear? Is this clear all of you?
Yes.
So these are the three important derivations. Definitely one will come in the exam. Okay.
So you substituted for R or you substituted for rho?
Rho, no? See, R is equal to rho into L by A.
Rho L by A.
See, this L will come in denominator, A will go in numerator, right?
Oh, okay. You're taking from that side. Okay, yeah, got it.
So if you cross multiply, okay, I'll remove this L also here.
No, sir, I got it. It's okay.
Okay, so M into N E square tau. Did we get that? The same
Yeah,
can be in terms of resistivity also. Conductivity also we can write. Is it clear all of you? Definitely you can think out of these three, one will come in the exam. No doubt about it. If they are not asking the derivation, definitely they will ask a numerical based on this. No doubt about it. Clear? On this, they asked 1 marker question also. Like on the formula, directly substitute the values. Please convert the units whenever you get this type of question. Okay? Clear all of you?
Yes, sir.
Okay.
Yes, sir.
Okay. Can I erase this and go to the next one?
Yes, so you can erase the first two. The last one I'm writing.
Okay. I'll erase the first one here, the first derivation. So I'm going with the series and parallel. I'm not going to solve the derivation here. Cell EMF and internal resistance is also left. Okay, that I will do it tomorrow. Cell EMF and internal resistance. The second one is cells in series, cells in parallel, Kirchhoff law, then numericals on Kirchhoff law, Wheatstone bridge. These 5 topics I will teach tomorrow. Okay, now these 5 topics I will teach tomorrow. Next one here we have. Okay, so resistance in series and parallel. We say combination of resistors. Combination of resistors. Resistances. So the combination of resistance first is series. In series, what happens? R is equal to what? RS is equal to R1 plus R2 plus dash dash dash. Okay, Rn. We can write like this. In series, what will happen? Current is constant. Current is constant, and voltage will be equal to what? V is equal to V1 plus V2 plus dash dash dash. When we add all the voltages, we get the actual voltage. Now coming to parallel. Coming to parallel, what is the formula here? Parallel is 1 by Rp is equal to what? 1 by R1, 1 by R1 plus 1 by R2 plus dash 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 1 by Rn. So here what happens? Current is divided. So here voltage is constant in parallel. Keep that in the mind. Voltage is constant. Current is equal to what? I1 plus I2 plus dash 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 In. This is the formula for parallel. Parallel. Is that clear? So series, parallel. And next one is what? Energy. Energy means what? Energy means capital E, which is known as ability to do work. Ability to do work is said to be energy. So energy formula is what? E is equal to what? VIT equal to I square RT equal to V square T by R. Equal to what? V square T by R. This is the formula for energy. And it is measured in what? Units of energy is in joules. Okay. Or we can write kilowatt hour also. So next is power. Power is rate of doing work. Rate of doing work is said to be power. The formula for power is, there are three formulas. P is equal to VI equal to I square R equal to V square by R. This is the formula for power. Okay. Now I'm erasing this one, just writing the value of 1 kilowatt hour. So here one kilowatt hour is equal to how much? 1 kilowatt hour is equal to 3.6 into 10 to the power of 5, or 3.5 into 10 to the power of 6 joules, something. Okay, or it is also known as 1 unit, 1 electrical unit. And 1 HP. HP is horsepower, which is equal to 746 watts. Please keep this in mind. Okay. This is about, energy and power and series and parallel. Is it clear, all of you?
Yes, sir.
So color code is deleted from the portions. I'm not going to teach that color code. Okay.
Yes, sir.
So if you have any doubts until now, please ask me now. Any doubt until here, until this part? In this lesson, meter bridge and potentiometer is deleted. Okay. And also color code is, these three topics are deleted now from this portion, from the portions. Now, should I go ahead with one more derivation? Cell EMF and internal resistance. Should I go with one more derivation? No one is replying.
Sir, your wish.
Huh?
Sure, sir.
Yeah, I didn't get you. Should I go ahead with the next one or should I stop here?
So you can go ahead. It's your wish, sir.
Okay, then I will go with one more derivation, cell EMF and internal resistance. Okay. So this is one more derivation. Then tomorrow I will teach you this cells in series and parallel. Okay. Now suppose there is a beaker in which we have taken some electrolyte. You are very good at chemistry. Okay. So I don't want to test your knowledge.
We are good?
Very good at chemistry, right?
Yeah. Oh, yeah.
Sir, we join Zoom and then we get 0.
Yeah.
Here there are 2 electrodes. Okay, positive and negative.
Yeah, at least I got 40 in physics. For 100% sure, I'll get 0 in chemistry.
Okay. So we have electrolyte. Electrolyte like zinc sulfide or zinc platinocyanide or zinc chloride, ZnCl2. Okay. So we can take some electrolyte in the beaker, and there are 2 electrodes. One is positive and negative. Positive electrode is known as anode, and the second one is known as cathode. Now this is connected to a resistor. Okay, this is connected to a resistor. So for the flow of current. In chemistry, you have very nice primary electrolyte, secondary cell, primary cell. So much classification is there in chemistry. Now here R is the resistance, and when I close the circuit, current should flow. So current should flow from this one. Okay. So Yeah. So just 1 second. Now, so what happens is the potential at this positive electrode is known as V plus. V plus, I'll write here. V plus is the positive potential and V minus is the negative potential. Positive potential. When we speak about one plate or one electrode, then we are speaking about potential. When we speak about the difference, then that is potential difference. Okay, when we speak about together, both of them, then it is potential difference. The total potential between here, let it be P and let it be N here. P and N. And now this is anode and cathode, and this point, there are 2 points here I have taken. Okay, so I'm removing this A and C, I'm writing A and B here. A and B here. So what do we get now? Here we write V plus plus V minus. The potential difference is given by is equal to what? V plus minus of minus V minus. So that will become V plus plus V minus. This is the potential difference. Now EMF is what? EMF is V plus V minus, which is greater than 0. What is EMF? Electromotive force. Electromotive force is not a force, but it is the work done to move a charge from one point to another point. Okay, I'll write the definition after this. Electromotive force. There are 3 definitions for this. Now what happens here? We have V is equal to the total voltage. The total voltage is equal to what? V plus V minus IR. What is R? R is said to be internal resistance. Again, what is the definition of internal resistance? That also I will write. Internal resistance is when we have cations and anions, right? Zn plus 2 and Cl minus 2. Is it not? Zn plus 2 and Cl2 minus 2. Is it not? Or Zn sulfide minus 2. What is this Zn plus 2 known as? Known as cation. And this is known as anion. Is it not? Positive cation and anion. So cation will move towards what? Not the cat. I'm speaking about cation. Cation is moving towards the negative electrode, and this will move towards the positive electrode. Is it not?
Not the cats.
No. I'm speaking about cation and anion. So cation cations move towards the negative ion and negative plate, and anions move towards the positive plate. Is it not? Opposite plates. When they are moving, there is a friction in the electrolyte. When they're moving, there is a friction in the electrolyte. That friction gives rise to resistance. That is known as internal resistance. So the definition says that resistance offered by the electrolyte is known as internal resistance. Okay, resistance offered by electrolyte. Resistance offered by electrolyte is known as internal resistance. Now this is known as what? V is equal to what? E minus IR. Now V is equal to IR, so we can write the first formula is we can write V is equal to E minus IR. Now this is the first formula. Second formula is what? IR is equal to what? E minus IR. Now E is equal to IR plus IR. So E is equal to what? I into capital R plus small r. Then we have I is equal to E by capital R plus small r. So we have maximum current is equal to what? E by R. Is that clear? There are 2 formulas here. These are the 2 formulas. See, once again, this is the potential difference is what? V plus plus V minus, and EMF is E is equal to greater than 0, and total voltage is equal to what? V plus plus V minus IR. IR is what? The resistance, the voltage, but R is what? R is the internal resistance. Internal resistance is when the cations are moving towards the negative plate and anions are moving towards the positive plate. There is a friction between the electrolyte. Thus, friction gives rise to resistance. That resistance is known as internal resistance. Internal resistance, in simple words, we define as resistance offered by the electrolyte. Now we have V is equal to E minus IR. Then simplify this, you get this first formula. This is one formula, second formula here. This is second formula. Definitely 1 marker can be asked on this one. And maximum current is this much. Okay. So I'll write the definition for, did you copy this one? I'll write the definition for EMF. Okay. The definition for EMF is what? Electromotive force. Electromotive force electromotive force. Electromotive force is not a force. Okay, it is the work done. It is the work done to move a charge from one point to another. From one point to another. That is said to be EMF. Or the second definition, maximum potential difference in the circuit. Maximum potential difference in the circuit is second. What is the third definition now? The third definition, it says potential difference of the cell when the circuit is open. When the circuit is open. This is the third definition. Okay. Is it clear? All of you?
Yes, sir.
Okay.
Yes, sir.
Okay. So thank you so much. So we'll stop here for today. Tomorrow I'll be going with cells in series parallel. Then I'll be doing Wheatstone bridge, Kirchhoff law, and numericals on Kirchhoff law. So that completes your chapter tomorrow, and day after tomorrow there will be a test on current electricity. Oh, sorry, 3 chapters, first, second, and third chapter. Please prepare well. Right on 31st, and first will be holiday. Okay.
Okay.
Thank you, sir.
you, sir.
Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much.